Hello, big boys and girls, parents and grandparents, and everyone interested in AI and robotics. I'm Anastassia, AI professor and the creator behind the Romy and Robbie series, and here with me, for those who are watching my podcast on YouTube, this is my fluffy co-worker and my inspiration, the real Romy. So together we are bringing to you AI Snacks with Romy and Robbie, a podcast for AI muggles, not wizards. We're translating AI and robotic technologies from difficult to easy to understand. I'm recording this episode in the last days of summer, and I feel quite sad because I need to say goodbye to vacation time. But still, I'm looking forward to those evenings when I can cuddle with my fluffy Romy and just read or watch Netflix. In the past 4 weeks, I was asking a lot of my Instagram followers what science fiction books I should portray on my podcast. I think we really learn a lot from novels, and they are sharpen our abilities to imagine how theoretical concepts might get translated into reality. 10 people asked me to do a podcast episode on AI and science behind three-body problem. And so I will cover some scientific concepts in the book Trilogy. So I will be focusing on the book rather than on Netflix movies. I won't be capable to do all the science from three-body. After today's episode, you will know what is the thing that the protagonist on Earth try to solve. And this is obviously this issue with the three-body system. You will know what are sophons and what do they have to do with quantum entanglement, whether the concept of communication utilizing quantum entanglement is possible at all, and whether particles like protons can truly disrupt the studying of physics on a planet, and whether we might consider those sophons as prototypes for some future AIs on Earth. And by the way, if you enjoy this very episode, please get in contact with me on social media, because I won't cover the whole science in the three-body trilogy. I will just do a fragment of it. And I might be capable to record a full episode on three-body and discuss virtual reality games, the consciousness question and its links to AI, and the dark forest theory, studying AIs, and exploration of space. So what is three-body for those who are completely unaware? It's a best-selling science fiction trilogy by Chinese writer Xiaoxin Liu. He is an engineer with a high-level understanding of physics and a huge love for physics. So I applaud him really. So three-body is full of science, from solar radio amplifications to near light speed travel, from nanofibers, particle accelerators to quantum entanglement. Three-body heroes and villains are all scientists, and those decisions they are taken and conflicts between them dictate the course of humanity now and in the distant future. So what is going on in three-body? In a nutshell, the three-body problem is basically a story of an alien invasion. The reason why the aliens are on the way to Earth is because they've evolved on a chaotic planet. And this planet is experiencing climate extremes, and those extremes cause civilizations to come and go. So those civilizations collapse when the climate gets, for example, too hot or too cold. And now they are confronted with the stable Earth. For the first time, they get aware about our planet in the 1970s. And those aliens called the Santi, they make a contact with a human female scientist from China. By the way, in Mandarin, Santi Ren means three-body people. There's another name for those aliens, and this is three Solarians. So like three solar suns within those systems. So the suns here are traveling from a star system 4 light years away. They are going at 1% the speed of light, and so it takes approximately 400 years to get from what they expect to become their new homeland, Earth. So before deep diving the science of sophons, those intelligent protons, let me discuss what is this thing, the three-body issue, the three-body problem. The three-body problem has existed ever since humans began to understand gravity and how it works. Our planet Earth rotates around the sun because the sun's gravitational field is exerting a pull over our planet. Earth's individual gravitational spheres are less powerful than the sun. Our moon, in contrast, is caught in Earth's gravitational field, so it floats along, hanging out with us. So in other words, two objects whose gravitational fields interact form stable orbits along a predictable path. And who did discover such a thing? That was Newton in 1687. And Newton, not only he figured it out, he developed a formula for predicting the orbits. If you were to introduce another star into the mix, you'd probably wind up with a binary star system where both stars form stable orbits around a gravitational center. And that's quite interesting. The most common sort of stars is one with a stable binary partner. This makes our sun, so our star, a solar star, a very rare event in the galaxy. Binary star systems can have stable planets. And these types of systems can often be mapped, plotted, predicted by physicists and by astrophysicists. And now comes a twist from the book. When you add a third object into the mix, the usual bets of gravitational theory are off. Instead of stabilizing, the third element creates chaos and causes the objects to interact in completely unpredictable ways, spinning off into space, crashing into each other, or bouncing off one another's gravitational spheres. So the key here is the law of conservation of energy. And that's the one that tells us that energy in a closed system can never be created or destroyed. Conservation of energy implies that a planet will orbit a single star forever and can never escape to infinity. In other words, once a planet becomes trapped inside of a star's gravitational field, it can't create the additional energy it would require to propel itself out of it. So, but two stars, on another hand, can exchange energy and possibly eject an orbiting planet. So we find ourselves in the three-body problem. How do we stabilize three gravitational objects or predict what their orbits might be? What are some possibilities for any civilization unlikely enough to be living on the planet with a three-body star system? And the central conflict of three-body problem is exactly this very scenario. Because of the three-body or three stars issue, these three suns exert gravitational chaos over one another. And they are wreaking climate havoc on the planet caught in the middle. But this very planet has civilization on it. And this alien race goes through cycles and cycles of destructions. And then they're coming back over and over for millennia. How realistic is such a scenario? So if life takes billions of years to evolve, as it did on Earth, then such a planet may not provide a suitable environment. However, there might be certain constellations of the three bodies that are stable for long times, and then those long times would actually inspire life to emerge. And this is precisely the situation for Trisolarians. From time to time, their tree bodies stabilize for long periods, giving their civilizations enough time to rapidly advance and flourish. Inevitably, the stable areas give way to chaotic areas, and then their suns resume their volatility. So in the course of the book, we see how Trisolarians try to get to Earth successfully, and they spy on our planet through the use of a proton that's been transmitted to Earth to act as a simultaneous receiver and transmitter for its twin proton, which remains Antisolaris. And now please pay attention. Exactly this situation is possible through quantum entanglement. What is quantum entanglement? Quantum entanglement is a fascinating phenomenon in quantum physics where two or more particles become linked in such a way that the state of one particle instantly influences the state of the other, no matter how far apart they are. So this connection persists even across vast distances, and this is a concept that Albert Einstein famously referred to as a spooky action at a distance, because it seems to defy classical intuitions about space and about time. So let me explain the concept in other words. Imagine two particles that are entangled. If you measure a property like a spin of one particle, you will immediately know that the corresponding property of the other particle is the same, even if they are light years apart. This does not mean that those two particles are communicating faster than light. Rather, those states are correlated in a way that classical physics cannot explain. In a three-body problem, an advanced alien civilization utilizes quantum entanglement to create sophons, which are essentially protons that have been unfolded into two-dimensional forms and then manipulated to serve as a kind of a supercomputing devices. These sophons are capable of instantaneous communication, and this allows the Trisolarians to spy on Earth and disrupt scientific progress by falsifying experimental data. So, sophon as a word is a kind of, a play with proton and the word sophont, which probably some science fi aficionados know to be an intelligent creatures. So, a sophon is an intelligent proton. So now let's examine, is such a concept real? So we know that quantum entanglement exists. This is real. But can such sophons or intelligent protons be used for communication while utilizing quantum entanglement? So in the book, the Earthlings are utilizing sophons for real-time communication with Trisolarians. But something like this is not possible in reality. Entanglement can't be used to pass information. The quantum mechanics does not allow for this. Entanglement means correlation, but not communication. So, by all means, if you take just one thing from this podcast, remember this. Quantum entanglement doesn't allow for communication, but it is all about correlation. So the second question for us is whether such sophons might be, in a realistic scenario, might be capable to cause a havoc in fundamental sciences. According to the book, the reason that sophons are capable of producing science lockdown is because they can falsify data coming out of particle accelerators. And we know that on our planet, physicists do fundamental science while using particle accelerators. Sophons can fly through sensors in particle detectors and trigger them falsely, creating noise. So it makes it impossible for humans to probe the deep structure of matter and therefore attain the understanding necessary to build such sophons themselves. And in the book, we see how many physicists are claiming that the physics as a science is at its end. And some of them commit suicide. So obviously all that looks bad. And it is a very interesting scientific or sci-fi idea, but it contradicts the very basics about how science is getting done, at least on our planet. So let me now provide several arguments against how Shixin Liu painted the use of sophons against studying fundamental physics. First of all, physicists are used to the concept of noise. So science, as a process of discovering something new, is intrinsically concerned with error checking and finding systemic interferences. When I was reading about sophons, I was thinking about intelligent fabrication of data within the scientific community. And unfortunately, we all know that something like this exists. It happens. But quite often it gets discovered and corrected. Of course, Earthling in the book know about the existence of sophons. So they know that they are being observed. So they are agents of their own destiny, and they might pay attention and build research on how to correct data collection and work against the utilization of sophons in particle accelerators. So they might, for example, examine where the real data sits when, for example, such a sophon provides a lot of noise and falsify the data. So the real data, as in theory, might sit somewhere behind a certain barrier which sophons constructed. And then machines like the Large Hadron Collider, they actually they are devoted to many lines of research. And those lines of research are carried out simultaneously. Physicists are adept at piggybacking one experiment on top of another in order to conserve resources and obtain additional bang for the same buck. So if aliens wanted to confuse human scientists completely, they would have needed to send to Earth more means to interfere with the scientific progress. So just sophons, powerful as they are, they might not have been enough. So this is the first argument. The second, it is really not clear for me how those sophons get their energy, their kinetic energy. Where is the engine allowing them to steer their movements in a self-contained manner, fly back and forth from the alien homeworld to Earth and maneuver on Earth without external assistance there? So this is something which is kind of a weak part of the plot. It is not quite clear. So my third argument, those sophons from the book seem to be like intelligent creatures making decisions and doing two things at once. So they spend time performing confusing behavior in order to foil their own direct examination. And then they spend time faking data in the experiments directed at basic research. So I tried to understand whether we had any scientific explanations of particles being intelligent as portrayed by sophons in the book. And in reality, particles such as protons are fundamental components of matter with no capacity for intelligence or computation. So quantum mechanics, the branch of physics that deals with the behavior of particles at the smallest scales, does not suggest that particles can process intelligence or consciousness. So those sophons, as painted in the book, as a little particle, microparticle, can't be intelligent agents in reality. The idea of intelligence particles challenges our understanding of physics and philosophy, while quantum mechanics has led to various philosophical interpretations and discussions about the nature of reality and consciousness. It does not support the notion of particles having intelligence. And then lastly, the scientists in the story declare the sophon barrier against their efforts to study physics, and those scientists are saying human science can't advance. So the issue is that particle accelerators aren't the only way to study physics and to do fundamental research. There's a huge branch of physics and chemistry probing quantum mechanics based, for example, on spectroscopy. Lasers are a quantum mechanical device, and the Nobel Prize winning discovery of the Bose-Einstein condensed matter phase did not occur on a super collider, but it occurred on an optical bench. Most super precise clock mechanisms used by the human race at this point are optical devices and have absolutely nothing to do with particle accelerators. So the leaps which are in the process of producing quantum computers today are not being made with particle accelerators at all. So if we stop being overcritical now, and if we forget about how the writer painted particle physics, if we just consider those sophons to be mysterious AIs with highly advanced problem-solving capabilities, then we find ourselves confronted with a very interesting perspective. And this is the concept of nano-sized AIs. So those AIs operating at the nanoscale. And in my personal opinion, this is a very intriguing area of research. So let me tell you what is going on today between AI and nanotechnology. AI is being used extensively in nanotechnology to enhance the design, synthesis, and characterizations of nanomaterials. So machine learning algorithms are analyzing complex data sets, and they are utilized to predict material properties and optimize the assembly of nanostructures. So there is a field of nanocomputing. It involves the development of computing devices at the nanoscale, potentially leading to significant advancements in processing power and energy efficiency. And AI today plays a crucial role in optimizing these processes and improving the functionality of nanoscale devices. And finally, AI is used today in conjunction with nanotechnology in medicine for drug delivery, diagnostics, and treatment planning. For example, AI algorithms help in the precise targeting of cancer cells using nanobots, which are still in the research phase. So there are several challenges in integrating AI and nanotechnologies. These include the need to exercise control and provide accuracy. The whole thing is tremendously complex. It's very difficult to work at the nanoscale. And of course, there are ethical and safety concerns associated with nanotechnologies. But here's the thing. If we get inspired by science fiction and just by the world of literature, Xuexin Liu is correct. He is saying there's no truly advanced civilization without mastering nanotechnologies. So I was speaking for 24 minutes, and I will stop here. If you liked what you heard, and if you are curious about science in free body, please address me on social media. I will record a separate episode, and I will discuss the use of virtual reality gaming technologies in the book. And I will reflect about how AIs are optimizing gaming technologies today in real life. And then, my fascination with consciousness research. There are tons of thoughts about AI and conscious machines in 3Body. And I would love to do an episode on how AI gets utilized in modern physics and astrophysics and space exploration. So goodbye for now. Follow Romy and Robbie on Instagram and follow me on X, former Twitter, and LinkedIn. And by the way, as a content creator, I really rely on your feedback. I'm learning every single day. And if you pre-order Romy, Robbie, and The Secrets of Sleep, it will fund some food for my fluffy companion, the real Romy. Thank you, and see you next week. Bye.